everyone, my name is Josicia. I'm informatics student from University of Ahmad Dahlan. Today I want to explain about how operating system manage tasks. Before we start talking about operating system, I want you to think about how often you use your computer every day. Maybe you open your laptop in the morning, check social media, watch videos, do assessment, listen to music, or play games. All of these things feel very simple to us. We just click an icon and the app open, but behind the simple action there is a lot of work happening inside the computer. The operating system is the one doing all of the work. Even right now, while I'm just talking and not opening anything away, the operating system is still running many tasks in the background. It's never really stopped working. That's why I understand how an operating system manages tasks is very important, especially for informatics students. In this video, I will explain everything slowly, and I will also show many live demos using Task Manager so you can really see what's happening. Now let me open Task Manager. I will open Task Manager. This one, Task Manager. Now you can look at these windows. You are basically looking inside the operating system. This is not fake data. Everything here is happening in real time. At the top, you can see CPU use, memory use, disk use, and network use. This number keeps changing because tasks are always running and stopping. Below that, you see a list of apps and background process. This list can be very long. That's how many tasks your operating system is managing at the same time. Let's focus on the app selection first. These are applications that the user open it directly. For example, right now you can see Microsoft Edge and OBS, Microsoft Edge, OBS, and Task Manager. These apps are visibly on the screen and we interact with them using the mouse and keyboard. When you open an app, the operating system creates a process for it. That process is monitored constantly. The OS checks how much CPU and memory the app is using and whether it is still responding. If an app uses too many resources, the operating system can slow it down or allow you to stop it manually. Now I will open another application. For example, I open Google Chrome and we watch a Task Manager carefully. You can see a new app in the list app. Now watch Task Manager carefully. You can see a new app appear in the list almost instantly. This shows how fast the operating system crack. Now I choose the application after a moment. From the list, when that happens, the operating system relates the CPU and memory that were used by the app. This open and close process may look simple, but involves many steps handled by the operating system. One interesting thing about modern application is that one app can actually run many processes. For example, Google Chrome does not run as a single process. Instead, it creates multiplied process for tabs, extension, and internal surface. This design helps improve performance and stability. The operating system manages all of this process separately, even though they belong to the same apps. Now I expand Google Chrome in Text Manager. You can see many process lists under it. Each one has its own CPU and memory use. They currently show how detailed task management is. The operating system does not just see Chrome. It sees many small tasks that must be controlled individually. Now let's talk about background process. Background process are tasks that run without user interaction. You usually don't open them, but they are very important. Examples include antivirus, service, system update, hardware drivers, and system monitoring tools. Without this background process, your system could become unstable or unsafe. Even though you don't see them on the screen, the operating system still manage them carefully and give them just enough resources to run properly. Now I slowly scroll touch the background process. You can see many different names here. Some belong to Windows, some belong to hardware manufacturer, and some belong to security servers. Most of them use very little CPU and memory, but together they play a big role in keeping the system running smoothly. The CPU is like the brain of the computer, but even the brain cannot think about everything at the same time, so the operating system acts like a traffic control. It tells one task to run for a short time, this switches to another task and then another. This switching happens extremely fast, 1,000 of times per second. That's why it feels like many apps are running at the same time. Without this system, your computer would freeze as soon as you open more than one app. Now let's look at the CPU columns. This in here. You can see which process is using the most CPU right now. If open or close an app, you can see the CPU number change immediately. This is real-time task scheduling in action. Memory or RAM is where apps store data while they are running. When you open many apps at the same time, memory use increases. If memory becomes full, the system slows down. Now let's talk about this activity. This activity is where all your files are stored. Every time you open a file, save something, or install a program, the disk is being used. The problem is many tasks want to access the disk at the same time. For example, one app may want to read a file, another app may want to save data, and the system itself may want to update some things. Now let's talk about network use. This one, network use. A network activity happen when applications send or revise data from the internet. For example, blowing website, watching video, or download file. The operating system manages network use so that one app does not use all the benefit. If that happen, another app will become very slow or even lost connection. Now let's talk about multitasking. Multitasking means running more than one task at the same time. For example, listening to music while browsing the internet and reading a document. In reality, the computer is not truly doing everything in the same times. Instead, the operating system, which is between tasks every quickly, it gives each task a small amount of time to run. The switch to other tasks happens so fast that we don't notice the switching. This is my modern computer feels smooth even when many apps are open. Now I will open several applications one by one. This one. We close for. As I do that, look at the Task Manager. You can see more tasks appearing and CPU and memory use flowy interacting. Now I switch between these apps, everything still feels smooth. Sometimes an application stops responding, maybe it's freeze or crazy. When that happens, the operating system gives control to the user. We can manually stop the task using Task Manager. This is very important because it prevents the whole system from freezing. Now I select a text in Task Manager. I click End Text. After that, you can see CPU and memory use go down. This shows that operating system immediately freeze the resource used by the task. So why is the task management is important? Imagine if the operating system did not manage tasks properly. One app could take all the CPU, another app could use all the memory, and the system would become unstable. Task management keeps the system stable, fast, and responsive. Every modern digital system depends on good task management. Now let's summary everything. The operating system is like a manager that never sleeps. It controls tasks, shares resources, and makes sure everything works together smoothly. Using Task Manager, we can actually see this process happening in real time. We can see running apps, background process, and system resource usage. Understanding this helps us use our computer more and also help us understand how system work at a deeper level. Thank you very much for watching this video. I hope this explain help you understand how operating system manage tasks in daily life.